As always, we will start with the top of the iceberg and slowly make our way down to the bottom. For those who want to skip the first tier of the iceberg, here's a timestamp you can skip to. Also, before we start the video, I want to inform you that space is huge, and I know you probably may be thinking that, but space is really huge. For those who don't know what a light year is, it is a unit we use to measure distance in space. For example, Earth and Pluto are not even 1% of a whole light year away. Keep that in mind because you will need a light year to compare the distances we use in this video. Thank you for watching and enjoy the video. Island universes are just galaxies in another word. The Great Debate, also called the Shapley-Curtis Debate, was held on the 26th of April 1920 in the Smithsonian Museum of Natural History. The two astronomers Harlow Shapley and Herbert Curtis presented their theories about space. Shapley presented that the Milky Way is the entirety of space, and spiral nebulas, like Andromeda, would simply be a part of the Milky Way. Many astronomers did not actually accept that because of the span of light years that is between these two universes. Curtis, on the other hand, contended that Andromeda and such other nebulas were separate galaxies, or, in other words, island universes. A multiple star system consists of two or more stars that appear to be close to each other from Earth. This may result from the stars actually being physically close and gravitationally bound to each other, in which case they are physical multiple stars, or the closeness may be merely apparent, in which case it is an optical error. Mostly they appear as triple stars, but systems with 4 or more components are less likely to appear. A nebula is a distinct luminescent part of the interstellar medium, which consists of hydrogen and also cosmic dust. Nebulas are often star-forming regions, such as in the Pillar of Creations in the Eagle Nebula. In these regions, the formations of gas, dust, and other materials clump together to form a denser region, which attracts furthermore matter, and eventually becomes dense enough to form stars. The remaining material is then thought to form planets and other planetary system objects. Most nebulas are of vast size. Some are hundreds of light years in diameter, but a nebula is visible to the human eye from Earth and would appear larger but not brighter from close distance. From close by, a nebula cloud the size of Earth would only have a mass of a few kilograms. A pulsar is a highly magnetized rotating neutron star that emits a beam of electromagnetic radiation out of its magnetic poles. This radiation can be observed only when a beam of emission is pointing towards Earth. Similar to the way a lighthouse can be seen only when the light is pointed in the direction of the observer. And it's responsible for the pulsed appearance of emission. Neutron stars are very dense and have a short regular rotation period. This produces a very precise interval between pulses that ranges from milliseconds to seconds for an individual pulsar. Pulsars are one of the candidates for the source of ultra-high energy cosmic rays, but we'll get to cosmic rays later in this video. The regular pulses make them a very useful tool for astronomers. For example, the observation of a pulsar in a binary neutron star system were used to indirectly confirm the existence of a gravitational radiation. A quasar is an extremely luminous active galactic nucleus. It is sometimes known as a quasi-stellar object. The emission from an active galactic nucleus is powered by accretion onto a supermassive black hole, with a mass ranging from millions to tens of millions of suns. Gas in the disk falling towards the black hole heats up and releases energy in the form of electromagnetic radiation. The radiant energy of quasars is enormous. The most powerful quasars have luminosities thousands of times greater than that of a galaxy, such as the Milky Way. Quasars are usually categorized as a subclass of the more general category of active galactic nucleuses. The redshifts of a quasar are of cosmological origin. About 1 million quasars have been identified with reliable spectroscopic redshifts, and between 2 to 3 million identified in photometric catalogs. The nearest known quasar is about 600 million light-years away from Earth, while the record of the most distant known quasar is about 31.7 billion light-years away. An exoplanet or extrasolar planet is a planet outside the solar system. The first possible evidence of an exoplanet was noted in 1917, but was not recognized as such. The first confirmed detection of an exoplanet was in 1992, and it was around a pulsar. As of December 2024, There are actually 5,811 confirmed exoplanets in 4,350 planetary systems. Almost all planets detected so far are within the Milky Way. However, there is evidence that extragalactic planets, exoplanets, located in other galaxies may exist. The discovery of exoplanets has intensified the interest in the search for extraterrestrial life. There is special interest in planets that orbit the star's habitable zone. However, the study of planetary habitability also considers a wide range of factors to determine suitability of a planet to hosting life. Star clusters are a large group of stars held together by self-gravitation. Two main types of star clusters can be distinguished. Globular clusters are tight groups of 10,000s of millions old stars, which are gravitationally bound. Open clusters are more loosely clustered groups of stars, generally containing fewer than a few hundred members. They are often very young. Open clusters become disrupted by the gravitational influence of giant molecular clouds. Even though they are no longer gravitationally bound, they will continue to move in broadly the same direction through the space, and are then known as stellar associations, sometimes even referred to as moving groups. A galaxy cluster or a cluster of galaxies is a structure that consists of anywhere from hundreds to thousands galaxies that are bound together by gravity. They are the second largest gravitationally bound structure in the universe, after some superclusters. Sagittarius A and A is a complex radio source at the center of the Milky Way, which contains a supermassive black hole. It is located between Scorpius and Sagittarius, and it's hidden from view at an optical wavelength by large clouds of cosmic dust in the spiral arms of the Milky Way. The dust lane that obscures the galaxy center from a vantage point around the Sun causes the Great Drift through the bright bulge of the galaxy. The radio source consists of three components: the supernova remnant Sagittarius A East, the spiral structure Sagittarius A West, and a very bright compact radio source at the center of the spiral, Sagittarius A, and these overlap. The Hubble Deep Field is an image of a small region in the constellation Ursa Major. It is constructed from a series of observations by the Hubble Space Telescope, and it covers about 2.6 arc-minutes on a side. That's about 24 millionth of the whole sky, which is equivalent to an angular size of a tennis ball at a distance of about 100 meters. The field is so small that only a few foreground stars in the Milky Way lie within it. Thus, almost all of these 3,000 objects in the image are galaxies, some of which are among the youngest that are known. This is basically a map that represents the best resolution we can get from galaxies. The cosmic microwave background, or CMB, is microwave radiation that fills all space in the observable universe. For a standard optical telescope, the background space between stars and galaxies is almost completely dark. However, a sufficiently sensitive radio telescope detects a faint background glow that is almost uniform and is not associated with any star, galaxy, or other object. This glow is the strongest in the microwave region of the electromagnetic spectrum. The CMB is the landmark evidence of the Big Bang theory for the origin of the universe. Gamma rays are immensely energetic events occurring in the distant galaxies, which represent the brightest and most powerful class of explosion in the universe. These extreme electromagnetic events are second only to the Big Bang as the most energetic and luminous phenomenon ever known. Gamma ray bursts can last from 10 milliseconds to several hours, and after the initial flash of gamma rays, a longer-lived afterglow is emitted. Our galaxy is shaped like a pinwheel, some 60,000 light-years in diameter, which rotates about the central axis. Our little planet and solar system are located far from the center of things, and gas and dust obstruct our view from galactic center. This effect is similar to a child sitting in the last row and trying to see something. The cloudiness of the center of our galaxy is almost apparent at the visual and ultraviolet wavelengths, which have received the most study. Our galaxy is, however, relatively transparent to the radiation, with energies greater than the several thousand of electron volts, and is completely transparent to gamma rays above hundreds of thousands and millions of electron volts. This is true because gamma rays are a much more penetrating form of radiation and pass nearly unimpeded through the dense clouds that surround the center of the Milky Way. Cosmic rays are very high-energy particles that move through space at the nearly speed of light. They originate from the Sun, from outside the solar system in our own galaxy, and from distant galaxies. Upon impact with Earth's atmosphere, cosmic rays produce showers of secondary particles, of some of which reach the surface, although the bulk are deflected off by the magnetosphere or the heliosphere of the Earth. Cosmic rays were discovered by Victor Hess in 1912 in the balloon experiment, for which he was awarded the Nobel Prize in Physics. The expansion of the universe is the increase in distance between gravitationally unbound parts of the observable universe within time. It is an aerostatic expansion, so it does not mean that the universe expands into anything or that space exists outside it. No. To any observer in the universe, it appears that all but the nearest galaxies, which are bound to each other by gravity, move away at a speed that are proportional to their distance from the observer, on average. While objects cannot move faster than light, this limitation applies only with respect to local reference frames and does not limit the recession rates of cosmological distant objects. Cosmic expansion is a key feature of the Big Bang cosmology. In physical cosmology and astronomy, dark energy is a proposed form of energy that affects the universe on the largest scales. Its primary effect is to drive the accelerating expansion of the universe, and assuming that the Lambda CDM model of the cosmology is correct, dark energy emits the universe, contributing 68% of the total energy in the present-day observation. Ordinary matter contributes like 26% of the universe, and other components such as neutrons and photons are nearly negligible. The first observational evidence for dark energy's existence came from a measurement of a supernova. In astronomy, dark matter is a hypothetical form of matter that does not interact with light or other electromagnetic radiation. Dark matter is implied by gravitational effects which cannot be explained by general relativity unless more matter is present that can be observed. Dark matter is not known to interact with ordinary baryonic matter and radiation except through gravity, making it difficult to detect in the laboratory. The most prevalent explanation is some as yet undiscovered subatomic particle, such as either weakly interacting massive particle or axions. The other main possibility is that dark matter is composed of primordial black holes. Dark matter is classified as cold, warm, or hot, according to velocity. The KBC void, or local hole, is an immense, comparatively empty region of space. The underdensity is proposed to be roughly spherical, approximately 2 billion light-years in diameter. As with other voids, it is not completely empty. It contains the Milky Way, the local group, and a large part of the Lincania superclusters. The Milky Way is within a few 100 million light-years of the void center. I actually don't know if that's a good or a bad thing. The Bootes void is an approximately spherical region of space found in the vicinity of the constellation Bootes, containing only 60 galaxies instead of 2,000 that should be expected from an area this large, is pretty small. It is almost nothing. With a radius of nearly 330 million light-years across, it is one of the largest voids in the visible universe and is referred to as the supervoid. In cosmology, galaxy filaments are the largest known structures in the observable universe, containing walls of galactic superclusters. These massive thread-like formations can commonly reach 50 to 80 megaparsecs, which are about 160 to 260 megalight-years, with the largest found to date being the Hercules Corona Borealis Great Wall, at around 3 gigaparsecs in length and form the boundaries between voids. Due to the accelerating expansion of the universe, the individual clusters of gravitationally bound galaxies that make up the galaxy filaments are moving away from each other at an accelerated rate. In the far future, they will dissolve. Galaxy filaments from the cosmic web define the overall structure of the observable universe. An astrophysical jet is an astronomical phenomenon where outflows of ionized matter are emitted as an extended beam along the axis of rotation. When this greatly accelerated matter in the beam approaches the speed of light, astrophysical jets become relativistic jets, and they show effects of special relativity. Messier 87, for example, is a supergiant apocalyptic galaxy in the constellation Virgio that contains several trillion stars. One of the largest and most massive galaxies in the local universe. It contains a giant black hole in the middle and a jet of energetic plasma that originates at the core and extends at least 1,500 parsecs, traveling at relativistic speed. An irregular galaxy is a galaxy that does not have a distinct regular shape, unlike a spiral or elliptical galaxy. Irregular galaxies do not fall into any regular cases of the Hubble sequence, and they are often chaotic in appearance, with neither a nuclear bulge or any trace of spiral arm structure. Hoag's object is an unusual ring galaxy in the constellation of Serpens Caput. It is named after Arthur Hoag, who discovered it in 1950 and identified it as a planetary nebula or a pellicular galaxy. The Tadpole galaxy, on the other hand, is a disrupted bare spiral galaxy located 420 million light-years away from Earth in the northern constellation of Draco. Its most dramatic feature is a trail of stars, which is about 280,000 light-years long. If you think about it, the distance between Pluto and Earth is less than 1 light-year. It's like 1% or less than 1% of a light-year. And 280,000 light-years is an unbelievably long distance, like the human mind can't even comprehend that. And then tell me you don't believe in extraterrestrial life. This is such a big distance that I don't know, it's pretty unlikely for me that there is really no life in such a big space. The Great Attractor is a region of gravitational attraction in the intergalactic space and an apparent central gravitational point from the Lakinia supercluster. This consists of galaxies that include the Milky Way, as well as about 100,000 other galaxies. The attraction is observable by its effect on the motion of galaxies and their association cluster over a region of hundreds of millions light-years across the universe. The Red Rectangle Nebula, so called because of its red color and unique rectangular shape, is a protoplanetary nebula in the Monoceros constellation. Also known as HD 44179, the nebula was discovered in 1973 during a rocket flight. On the other hand, we have the Boomerang Nebula. It is a protoplanetary nebula located 5,000 light-years away from Earth in the constellation Centaurus. It is also known as the Bow Tie Nebula, and the nebula's temperature is measured at -272 degrees or -457 degrees Fahrenheit, making it the coldest natural place currently known in the universe. The Boomerang Nebula is believed to be a star system evolving toward the planetary nebula phase. Tabby's star is a binary star in the constellation Cygnus, approximately 1,470 light-years away from Earth. The system is composed of an F-type main sequence star and a red dwarf companion. Usually light fluctuates of Tabby's star, including up to a 22% dimming in brightness. This was discovered by citizen scientists as a part of a project. Several hypotheses have been proposed to explain why the star has such irregular changes in brightness, but as of 2024, none of them fully explain all aspects of the resulting light curve. It has been suggested, and this is on the official Wikipedia site, that this could be an alien megastructure, but evidence tends to discount this suggestion. Przybylski star, or HD 101065, is a rapidly oscillating star. It's roughly 356 light-years away from the Sun in the Centaur constellation of Centaurus. It is a little bit unique because it has rare Earth-like elements and a lot of radioactive isotopes, but mostly it is common elements such as iron. Because this is not really typical for any planet, it made it to the list. A magnetar is a type of neutron star with an extremely powerful magnetic field. The magnetic field decay powers the emission of high-energy electromagnetic radiation, particularly X-rays and gamma rays. The existence of magnetars was proposed in 1992 by Robert Duncan and Christopher Thompson. Their proposal sought to explain the properties of transient sources of gamma rays, now known as soft gamma repeaters. Over the following decade, the magnetar hypothesis became widely accepted and was accepted to explain the anomaly of X-ray pulsars. The Oh My God particle was an ultra-high energy cosmic ray detected on the 15th of October 1991 by the Flying Ice Camera in Utah, United States. As of 2025, it is the highest energy cosmic ray ever observed. Its energy was estimated at I can't even read this out for you. The particle's energy was unexpected and called into question prevailing theories about the origin and proportion of cosmic rays. A blazar is basically a jet composed of ionized matter traveling nearly at the speed of light, and is directed very nearly towards an observer. Relativistic beaming of electromagnetic radiation from the jet makes the blazars appear much brighter than they will appear if they were pointed in a direction away from Earth. Blazars are more powerful sources of emission across the electromagnetic spectrum and are observed to be sources of high-energy gamma-ray photons. Now about rocoses. They are considered to be a subclass of blazars and are similar in their spectral characteristics to DC dwarfs and single-stellar mass black holes. NGC 1052 DF2 is an ultra-diffuse galaxy. It has been proposed that the galaxy contains little to no dark matter, the first such discovery. The apparent lack of dark matter in this galaxy may help prove that dark matter is real, and if that what appears to be dark matter is really just a currently unknown effect of the gravity, or ordinary matter, then this apparent dark matter should also appear in this galaxy. But for now, it is a special object in space. The WOW signal was a strong narrow radio-bound signal detected on the 15th of August 1977 by Ohio State University. It used to support the research of extraterrestrial intelligence. The signal appeared to come from the direction of the constellation Sagittarius and bore expected hallmarks of extraterrestrial origin. Astronomer Jerry R. Ammon discovered the anomaly a few days later while reviewing the recorded data. He was so impressed by the result that he circled on the computer spread out the reading of the signal, 6EQUJ5, and wrote the comment "Wow" beside it, leading to the event widely used the name. The entire signal sequence lasted for about 72 full seconds, during which the telescope was able to observe it, but has not been detected since. Despite many subsequent attempts by Eman and others, several hypotheses have been made and advanced the origin of emission, including natural and human-made sources. The giant GRB ring is a ring of 9 gamma-ray bursts that may be associated with one of the largest known cosmic structures. It was discovered in July of 2015 by a team of Hungarian and American astronomers. It was found while analyzing data from different gamma-ray and X-ray telescopes, in particular the Swift spacecraft. The ring of GRBs lies at a distance of about 2.8 gigaparsecs, which is like 9.1 billion light years away from Earth. In diameter, they measure like 5.6 billion light years, which is just an immense amount of light. The thing that you see here on the screen is a short period variable star in the constellation Hydra. It has a galactic rest frame radial velocity of 709 kilometers a second. It is called the Outcast star, and it's the first discovered member of a class of objects named the hypervelocity stars, which just move at an ultra high speed. It is almost double as hot as the Sun with 20,000 degrees in Fahrenheit, and its age is estimated to be at almost 350 million years. It was ejected from the center of the galaxy less than 100 million years ago, which implies the existence of a population of young stars at the galactic center less than 100 million years ago. If you think we already mentioned the fastest things in space yet, a millisecond pulsar is a pulsar with a rotational period less than about 10 milliseconds. Millisecond pulsars have been detected in radio, X-ray and gamma-ray portions of the electromagnetic spectrum. The leading hypothesis of this origin of a millisecond pulsar is that they are old, rapidly rotating neutron stars that have been spun up or recycled through acceleration of matter from a companion star in a closed binary system. For this reason, million pulsars are sometimes called recycled pulsars. For example, this right here is the fastest spinning pulsar known. It spins 716 times per second, or it makes 42,960 revolutions per minute. This pulsar was discovered in 2004 and confirmed in 2005. If the neutron star is assumed to contain less than 2 times the mass of the Sun, within the typical range of neutron stars, its radius is constrained to be less than 16 kilometers. At its equator, it is spinning approximately 24% of the speed of light, or over 70,000 kilometers per second. Galaxy S is a dark satellite dwarf galaxy of the Milky Way. If it exists, it will be composed mostly of dark matter and interstellar gas with a few stars. Observable evidence for this galaxy was proposed in 2015, based on the claim of discovery of 4 Capites. The mass would be calculated about 1% of the Milky Way, which would make it the third heaviest satellite of the Milky Way, after the Magellanic Clouds. PHL 293b, also known as Kinman's dwarf, is a low metallicity blue compact dwarf about 22.6 megaparsecs from Earth in the constellation Aquarius. It has a very likely associated notable blue light and a long-lived star, with constant outbursts of supernovas. It is now faded and disappeared, but it was a visible jet-producing object responsible for broad hydrogen emissions. Because of its bright light, it was a mystery for scientists, but there are several theories why there is a bright light source within it, but none of them are really confirmed. A superluminous supernova is a type of stellar explosion with a luminosity of 10 or more times higher than that of a standard supernova. Like a supernova, it seems to be produced by several mechanisms, which is revealed to be their light curves and spectra. The first confirmed superluminous supernova connected to a gamma ray burst and was not found until 2003. When the giant gamma ray burst illuminated the Leo constellation, it could be seen. SN 2018 Cow was a very powerful astronomical explosion, 10 to 100 times brighter than a normal supernova, and it consisted in a galaxy approximately 200 million light years away from Earth in a distant Hercules constellation. Sage 1 is a dwarf galaxy or globular cluster situated in the Leo constellation and was discovered in 2006. This allegation may be caused by the tidal forces acting from the Milky Way galaxy if Sage 1 is being tidally disrupted now. The stellar population of Sage 1 consists mainly of old stars formed more than 12 billion years ago. The metallicity of these old stars is very low, which means that they contain 300 times less heavy metals than the Sun. Currently, there is no star formation in this galaxy, which makes it very special. SCP-06F6 is, or was, an astronomical object of unknown type, discovered on the 21st of February 2006 in the constellation Bootes. And no, this is not some kind of monster from the SCP series. This thing is, or should be, real. According to research, the object brightened over a period of roughly 100 days, reaching a peak intensity of a magnitude, and then it faded away over a similar period. Scientists reported that the spectrum of light emitted from the object does not match known supernova types, and it is dissimilar to any known phenomenon in the database. The light in the blue region shows broad line features, while the red region shows continuous emissions. The spectrum shows a handful of spectral lines, but when astronomers try to trace one of them to an element that is known, it just doesn't line up, because it's not an element that we know. Because of this uncommon spectrum, the team was not able to determine the distance of the object using standard redshift techniques, but it is not known either if the object is within or outside of the Milky Way. Furthermore, there is no Milky Way star or external galaxy that has been detected at this location at all, meaning any source is very faint. The cosmic microwave background cold spot is a region of the sky seen in microwaves. And no, I don't mean the microwaves you have in your kitchen. Microwave is a form of electromagnetic radiation with wavelengths shorter than that of a radio, but longer than that of infrared waves. It has been found by usually large and cold relatives to the expected properties of a cosmic microwave background radiation. The cold spot is approximately minus 495 degrees in Fahrenheit, and it's colder than the average CMB temperature. Typically, the largest fluctuations of the primordial CMB temperature occur at an angular scale of about 1 degree, though a cold region as large as the cold spot appears very unlikely to exist. Various alternative explanations exist, including a so-called supervoid or great void that may exist between us and the primordial CMB. Such a void would affect the observable CMB and would be one of the largest structures in the observable universe. The galactic center excess is an unexpected surplus of gamma-ray radiation in the center of the Milky Way. This spherical source of radiation was first discovered in 2009, and astronomers argue that self-annihilating dark matter may be the cause of this galactic center excess, while others prefer a population of pulsars at the source. The axis of evil is a name given to an substantiated correlation between the plane of the solar system and the aspects of the cosmic microwave background. At one scale, the random fluctuations of the radiation seem to align in a preferred direction that has been dubbed the axis of evil, as it threatens the models of the nature of the background radiation. The Interstellar Boundary Explorer is a NASA satellite in Earth orbit that uses energetic natural atoms to image the interaction regions between the solar system and interstellar space. IBEX is a sun-oriented spin-stabilized orbit around the Earth, and the mission was originally planned to be a 24-month operation period. The mission since has been extended, and the spacecraft is still in operation as of 2024. The Interstellar Boundary Explorer's mission is to discover nature of the interactions between a solar wind and the interstellar medium at the edge of the solar system. It is on the list because it's just a crazy technology that we as humans are able to create and send into space, so it's one of the greatest space objects we have so far. Olbers paradox, also known as the Dark Knight paradox, is an argument in astrophysics and physical cosmology. It says the darkness of the night sky conflicts with the assumption of an infinite and eternal static universe. In the hypothetical case that the universe is static, homogeneous, and at a large scale populated by an infinite number of stars. Now comes the fun part. Any line of sight from Earth must end at the surface of a star, or at some kind of mass. So the night sky should be completely illuminated by a very bright blast. This contradicts with the observer's darkness in the night sky. The darkness of the night sky is one piece of evidence for a dynamic universe, such as the Big Bang model. Galactic antimatter photons are basically clouds of antimatter, which can be ejected by a pulsar. One has been found near the center of the Milky Way. It was first discovered in 1997, who didn't really expect this. It's a big discovery, but sadly there is not much more due to it. But it's probably one of the areas of the galaxy you want to avoid, unless you want to get torn apart by positrons. In physical cosmology, the baryon asymmetry problem, also known as the matter asymmetry problem, is the observed imbalance of matter in the observable universe. The Big Bang should have produced equal amounts of matter and antimatter. Since this doesn't seem to be the case, it is probably some physical laws that must be acted differently or did not exist from matter or antimatter. Several competing hypotheses exist to explain the imbalance of matter and antimatter that resulted in baryogenesis. However, there is as yet no conscious theory to explain the phenomenon, which has been described as one of the great mysteries in physics. An electric current is a flow of charged particles, such as electrons or ions, moving through an electrical conductor or space. 3C303 is a galaxy which is located in a region with little to no galaxies laying next to it. It has a jet, which proved to be the first time in history that a jet travels through space with electricity. The horizon problem, also known as the homogeneity problem, is a cosmological fine-tuning problem with the Big Bang model of the universe. It arises due to the difficulty in explaining the observed homogeneity of casual disconnected regions of space, in the absence of a mechanism that sets the same initial conditions everywhere. In other words, the two opposite sides of space from one point to another are so far away from each other that you could take the theory both sides never were in any relation to each other during the Big Bang. The most commonly accepted solution to this is cosmic inflation. And cosmic inflation basically means it is a faster than light expansion of the universe that spawned many others. Yeah, something faster than light. Astronomers have discovered a mysterious new class of objects at the heart of the Milky Way. And unlike anything else found previously in our galaxy, these objects look like gas but behave like stars. According to senior researcher Andrea Gass, as they start off small and compact, they stretch and become larger when they approach the supermassive black hole in the center of the galaxy. The researchers believe that these objects could teach us of the evolution of stars and what happens to celestial bodies in the environment of extreme gravity. The puzzle began in 2005 when astronomers identified an object near the center of the galaxy called G1, which seemed to be orbiting around a supermassive black hole where there was a strange way. In the following years, 5 more objects named G2 to G6 were discovered, and first these objects were thought to be clouds of gas, but one odd thing researchers noticed was that the object G2 came very close to the event horizon of the black hole. It wasn't torn apart in the way that they would expect it. Instead, it initially stretched out before rounding back towards its original state. Sadly, the exploration of G objects is so new that we have little to no further info to this topic. The Fermi bubbles are spheric structures. They're perpendicular and centered on the gravitational center of our galaxy. This phenomenon was discovered in 2014. There is many theories of how this phenomenon occurs, but the most common one is a starburst in the middle of the Milky Way. In astronomy, a fast blue optical transient, or more specifically, luminous fast blue optical transient, is an explosive transient event similar to a supernova and gamma ray bursts, with high optical luminosity, rapid evolution, and predominantly blue emissions. The origin of such explosions are currently unclear, with events occurring at not more than 0.1% of typical core collapse supernova rates. This class of transients initially emerged from the Large Sky Survey at cosmological distances, yet in recent years a small number have been discovered in the local universe. In astronomy, an odd radio circle is a very large unexplained astronomical object that, at radio wavelengths, is highly circular and bright along its edges. As of 27th of April 2021, there have been 5 such objects observed. They are not visible, and infrared or X-ray wavelengths do not reach them. This is due to the physical process producing this radiation. There are only 3 of the odd radio circles that contain optical galaxies in their centers, suggesting that the galaxies might have formed these objects. In radio astronomy, a fast radio burst is a transient radio pulse of a length ranging from a fraction to a millisecond for an ultra-fast radio burst to 3 seconds, caused by some high-energy astrophysical processes not yet understood. Astronomers estimate that the average FRB releases as much as energy in a millisecond that the Sun puts in 3 days. While extremely energetic at their source, the strength of a signal reaching Earth has been described 1,000 times less than a mobile phone reaching to the moon, so it's basically impossible to reach us. Because of the isolated nature of the observed phenomenon, the nature of the source remains speculative. As of 2022, there is no generally accepted single explanation. Although a magnetar has been identified as a possible source, the sources are thought to be a few hundred kilometers or less in size, as the bursts last only for a few milliseconds. And so we come to the greatest thing on our list. Scientists have struggled with the mysterious signal that they received in the 90s, given the name periton from the mythological creature that is half deer and half bird. In radio astronomy, peritons are short man-made radio signals of a few milliseconds resembling fast radio bursts. A periton differs from a radio frequency by the fact that it is a pulse of several tenths of milliseconds, but the duration sweeps down in the frequency. The first signal occurred in 2001, but was not discovered until 2007. Now here comes the interesting part. The title of the mysterious radio signal, called periton, that mimicked the signal of deep space, were detected only at the Parkinson Observatory in Australia. They were actually caused by opening a microwave's oven door early. If that isn't the best space object signal we received, then I don't know. Thank you so much for watching. I hope you enjoyed this video, and leave a like if you did so. I hope I could show you how big space is, and hopefully you're not that scared. Have a nice time, and see you in the next video.